Imagine your car seeing a pedestrian like a split second before you do, or a camera that can spot a wildfire from miles away, or even diagnose a disease just from a single scan. Well, this isn't science fiction anymore. This is the world being built right now by computer vision. Today, we're going to dive into how we're teaching machines to see and how that is about to change, well, pretty much everything.
All right, let's start with something you probably do a dozen times a day without even thinking about it. You pick up your phone, you look at it, and bam, it's unlocked. But have you ever really stopped to wonder what's actually happening in that tiny moment? How does this little slab of glass and metal know that it's you and not one of the other 8 billion people on the planet?
Well, the answer comes down to two simple words: computer vision. It's kind of like the invisible brain behind the camera, giving our devices the power of sight. And believe me, it's already working all around you in ways you probably don't even realize.
So what is it really? Think of it this way. A normal camera can capture a picture of a cat, right? But it has absolutely no idea that it's a cat. To the camera, it's just a bunch of colored dots. Computer vision is the AI, the brain, that we give the camera. It teaches the machine to do what our brains do instantly. So look at that image and understand, okay, that's a cat, it's furry, and it definitely looks like it's about to knock that glass off the table. It's the huge difference between just seeing and actually understanding.
Okay, so how on earth do you teach a computer to do that? How do you get a machine to go from seeing a jumble of pixels to having a real-world insight? Let's pop the hood and take a look at how this whole thing works. So first, the AI gets an image, but it doesn't see a picture like we do. It sees this massive grid of numbers, kind of like a giant paint-by-numbers canvas where every single number stands for a color. That's step 2. It's all about translating the image into a language computers can speak. Then comes the really clever part: feature extraction. The AI basically acts like a detective, scanning that grid for clues. A straight line here, a sharp curve there, a patch of this specific color. It learns to recognize all the tiny fundamental patterns that make up an object. And finally, after it's collected all the clues, it makes a prediction. Okay, based on all these patterns, I'm 99% sure this is a human face. And that's it. That's literally how a machine learns to see. And here's a perfect example of how that process can save lives. A self-driving car's camera grabs a video frame. That's the input. The system instantly translates that frame into numbers, extracts the patterns that perfectly match a person walking, and makes its prediction: pedestrian in the road. That prediction immediately triggers an action: hit the brakes. All of that happens way faster than a human can even blink. Now, here's the thing. Not all computer vision is the same. Just like you wouldn't use a hammer to turn a screw, you need different AI models for different visual jobs. Think of it as a team of highly trained specialists, and each one has a unique superpower. Let's meet the crew.
First up, you've got CNNs. These are the detail-oriented detectives. They are incredibly good at recognizing complex patterns, which makes them perfect for your phone's Face ID or for helping a radiologist spot a tiny tumor on a medical scan. Next, meet YOLO. Its superpower is pure speed. It can identify tons of different objects in the scene in real time, which is absolutely critical for a self-driving car that needs to track other cars, pedestrians, and traffic lights all at the same time. Then you have vision transformers, the powerful new all-rounders that can analyze an entire scene with just astonishing context and accuracy. And finally, you've got the GANs. These are the creative artists of the group. They don't just see images, they can actually create brand new photorealistic ones from scratch. They power everything from mind-blowing AI art to, well, less savory things like deepfakes.
So we've met the specialists. Now let's actually see where they're working. And this isn't some far-off futuristic technology we're talking about. It is already deeply woven into our daily lives.
It's the Face ID on your phone and those fun social media filters. It's Google Lens, which turns your camera into a visual search engine for the entire world. It's the core technology inside Tesla's autopilot, helping it navigate highways. In our hospitals, it's a tireless assistant, helping doctors identify diseases with almost superhuman accuracy. And in security, it's the system that can spot a problem in a crowded airport and flag it for attention. It has quietly become one of the most important technologies of our time.
So yeah, this paints a picture of a technology that is just unbelievably powerful. But like any powerful tool, it's not magic. And it's really important to have a clear-eyed view of both its incredible strengths and its very real limitations.
I mean, the strengths are a total game changer. We're talking about machines that can do visual tasks faster and sometimes even more accurately than the best human experts. And that's paving the way for a whole new era of automation. But this power definitely has its limits. These systems can get completely confused by something as simple as a blurry image, a rainy day, or even an unusual camera angle. And the amount of data and raw computing power it takes to train one of these top-tier models is just staggering. So the crucial point to remember is this: while their vision is sharp, they don't have common sense. They're only as good as the carefully selected data we feed them.
So the big takeaway here is this. Computer vision isn't just another app for your phone. It's a foundational technology, a core pillar that is literally reshaping entire industries. It's fundamentally changing how we and our machines interact with the physical world around us.
And that leaves us with a really fascinating question. We know this technology is only going to become more powerful and more embedded in our world. So as AI's vision continues to get sharper and sharper, the real challenge for us is to harness its incredible potential while always understanding its limits. It's not really a question of if machines will see more, but how we'll choose to navigate a world where they do.